All right, another factoring video here. First thing I would tell you though is if you're going to factor, make sure you look for a GCF first, then worry about some of the other ones. So we're going to talk about difference of two squares and eventually talk about quadratic trinomials. But for right now, we'll just make sure that we look for a GCF. A couple things though before we get completely going. Let's talk about simplifying a couple of specific cases. You guys learn in Algebra 2. If I do have two different binomials and I'm breaking it down and simplifying, meaning I'm getting rid of this. Now remember, factoring is the opposite. It's taking something and putting it in parentheses. But if I was to break this down on our own, we would remember that we have to do x times x. That's going to give me an x squared. X times a negative 3 minus 3x. 3 times x plus 3x. And then 3 times negative 3 gives you a minus 9. Whenever we've done this too, though, we've looked here and combined a like terms. Well, negative 3x plus 3x cancels. So then my final answer is x squared and then minus 9. Now, a couple things to remind you about that. These binomials looked almost identical, except one had a plus and one had a minus. Otherwise, they were almost the exact same thing. Then, if you noticed, what happens where my middle terms cancel out and I was left with this term minus and then this term. We'll talk about that one in a second. Next over here, I've got 2x times 2x, so that's going to give you 4x squared, because 2 times 2 is 4, x times x is x squared, 2x times a plus 1, 2 times plus 1 is 2, so I'll bring the x down, and then negative 1 times 2x, that's a negative 2x, and then negative 1 times 1, that would give me a negative 1. Middle terms again cancel out, and that would give me 4x squared minus 1. So if I go back here, 2x minus 1, 2x plus 1. So they're almost identical. The signs in the middle are different. We call those conjugates. So we're going to talk about that. What we're going to do is go from something like this to something like that. Now notice that if I do that, my middle term here is a minus sign. If it's a plus, I can't do what I'm about to do. So that's really important. So here we go. One way to do this, and if I go back to this last slide, you can kind of look at, I'm going from here to something like this. So if I'm going from an x squared and then minus 9, and I look, I've got x's here and I've got 3's here. Well, 3 is the square root of 9. If I go to this example, if I square root 4x squared, that'll give you a 2 and an x, because the square root of 4 is 2. And if I square root x squared, that'll cancel and give you an x. The square root of 1 is 1. And then notice one's a plus, one's a minus. And it doesn't matter if there's a plus or a minus first or second, as long as there's one of each. So if I go factor this one, same thing. Sometimes people like to write out and say, well, let me square root x squared. Let me square root that 16. So the minus there is to establish what the pattern is, but we're not going to actually square root it, otherwise it's a complex number. But what happens is a square root and a square cancel, and that leaves you x. The square root of 16 is 4. So if I go back to my pattern that I just kind of learned, I got x first, that's going to go the first in each parentheses. When I square root 16, I got 4, that's going to go the second in each parentheses. And as I just said, you're going to have 1 plus and then 1 minus. That's factored with difference of two squares. So once you figure out what the pattern is, these become pretty quick. If you want to double check, you can undo this. X times x, that's x squared. X times negative 4, that's a negative 4x. 4 times x, that's a plus 4x. 4 times negative 4, that's a negative 4. You'll have the middle terms cancel out and you'll be left exactly where we started with. So that's another way to check your answer. So here, same thing. You're mainly looking for a lot of perfect squares. Take the square root of 1, take the square root of b squared. So the square root of 1 is just 1. That square and square root cancel, that just leaves me b. So when I go to my pattern, I got 1 first, that's going to go first. I got b second, that's going to go second. And as long as I have a plus between one and a minus between the other, I'm done. If you had 1 minus b and then 1 plus b, that's 100% fine too. So now I have a couple of perfect squares here. So I'm still going to kind of do the same thing. And a lot of people don't even write these out. They just take the square roots, but I just want to remind you what we're kind of doing here. That's going to help us with our pattern. Well, the square root of 25 is 5. And then the square root of x squared is just x. Here, the square root of 81 is 9. Taking those two things, I got 5x first. I got 9 second, so it goes second. and then one's a plus and one's a minus. And again, if you wanted to distribute these out and confirm that you're getting that, that's a great idea too, because it's easy to make mistakes. I get a lot of people giving me that answer would be 5x plus 81 and 5x minus 81 because they forget to take the square root. That happens, so just be careful. In this case, I got a couple of perfect squares, and I also have a few variables here. So I'm going to take the square root of the first term, the square root of the second term. So the square root of 36 is 6. C squared, square root that, that's just that. So I get 6c. This one would give me 7d. And then when I go to write it, I know I'm going to have a 6c plus 7d and a 6c minus 7d. And then that's factored. Here we go. If I go to this one, the difference between this one is I have perfect squares and perfect squares here, but I have a plus. I can't do that. There's no rule that says that this one's not factorable. So it's easy to want to say it's x plus 5 and x minus 5, but if you try to actually take that x plus 5 and x minus 5 and multiply it and distribute it out, you'll have middle terms canceling, and it won't be a minus 25 at the end. So anytime you can't factor this. Now again, always look for a GCF. I don't have a GCF. There's nothing else I can do in this problem. Now 6 is not a perfect square, but we're still going to be able to factor this. We're not always going to use this technique. Typically speaking, if it looks like that, we're probably going to leave it alone. But this technically can be factored with difference of two squares. X squared, the square root of that's x. The square root of 6 is just the square root of 6. I don't want a decimal here in an irrational number. But I can put the x's in front. The square root of 6, I can leave the square root of 6. And then I can put one's a plus and one's a minus. So that's another way to kind of factor, although it doesn't look as nice as it usually does. And we won't always use that, but it's still worth mentioning that sometimes you can use difference of two squares in that case. But again, unlike the last example, it has to be a minus between them, which I do have here, which means I can't go a step further. And finally, instead of having an x to the second power, we can still do this. So I can have an x to the fourth, and then the square root of that. The square root of 100 we know is just 10. Now here, remember, this is like a second root. If you're taking an exponent underneath there, there's a rule that tells us essentially we can take this exponent and divide it by this root. So 4 divided by 2 is going to give you 2. So the square root of x to the fourth is x squared. So once we have that, I'll put an x squared in front because I got it first, a 10 second because I got it second. One has to have a plus, one has to have a minus. And so it looks like that. Hope this helps. Thanks.